Hi, hello friends, welcome back to my YouTube channel. Let's continue Uttar Pradesh Power Corporation Limited AE 2016 paper solutions. Okay, so let's continue from the previous session. The power developed by a DC motor is maximum when the ratio of back EMF and the applied voltage is. The ratio of back EMF and applied voltage should be the ratio of back EMF and applied voltage. So the answer for this one is the ratio of back EMF to the supply voltage should be 1 by 2. That means 2 into EB is equal to V and the EB is equal to V by 2. So ratio. Suppose for example if V is say 220 volts and the back EMF should be half of it. That means it should be 110 volts. Okay, that's the meaning of this question. So the answer here it is half. Now next question, 62nd question here. It is also from the DC machines. Now a DC series motor is running with a diverter connected across the field winding. A DC series motor is running with a diverter connected across the field winding. If the diverted resistance is reduced, then the speed of the motor will be. Now let's take a DC series motor here. Okay, so let's take a DC series motor with this winding. I'm just showing a number of turns here to make you understand. Just in practical case there will be only few turns are there, and let's make this is a DC series motor here and the applied voltage is V here like this. Okay, now there is a diverter here, so diverter is like this. Now what is happening here is we are decreasing the diverter resistance. So diverter resistance means this part we are diverting. Now what we are doing is we are reducing this part here. So as we are reducing this part, so what is going to happen here? So as we are decreasing this part, the resistance of the field is going to be increases. Okay, now if the resistance of this field winding is going to be increased, because we are increasing the number of turns. Okay, like this. So once we decrease means the entire current will flow like this. So length will increase, automatically resistance will increase. As a resistance will increase, resistance of the field will increase. Because of that reason, the flux is going to be decreases. As the flux decreases, what about the speed? Speed we have basic relationship EB. Okay, back EMF N is proportional to EB by 5. That means speed. Now as the flux decreases, what about the speed? Automatically speed will increase. So the answer for this question is it is increase in the speed. Now next question, 63rd question here. Now the displacement density and the electric field strength E is related as. So this question is from the EMF. Now the displacement density D can be written as the permittivity epsilon into E. So this is a basic relationship here, which can also be written as D is equal to epsilon naught into epsilon R into E. So where E is nothing but electric field intensity. So this is an important relationship. Okay, next question you can see now here. So it's a theory question. It is from the measurements, right? Now a dynamometer type wattmeter responds to. So dynamometer type wattmeter responds to average value of active power only. Okay, so P is equal to VI into cos phi. Now next question, which of the following transfer function is phase lead compensator? So before going to discuss about the phase lead concept, the basic thing about the phase lead concept is there should be 0 nearer to the origin. So there should be a 0 near to the origin after there is a pole. So for phase lead, the important point you should keep in mind, it is 0 nearer to origin. So keep this point in your mind. Now here 0 should be in origin. Among the options here, so directly I am going for answer here. If you want, you can cross check the other options also. That is, if you make it 2 common here, S plus 1 divided by S plus 2. So S plus 1 denotes what? It is a 0 or pole? It is 0. S plus 2 is nothing but a pole. So S plus 1 means S is equal to minus 1. We have 1 0. And S is equal to minus 2. We have 1 so pole, so 0 is at -1 and -1 here, and s is equal to -2 here. Okay, so the answer is 3 here. So next we'll move to the next question here. Now 66th question. For the same voltage output, which one of the following has largest peak inverse voltage of the thyristor? I will repeat the question again. For the same voltage output, which one of the following has the largest peak inverse voltage of the thyristor? So it is single phase full wave center tapped circuit. Why? Because in a center tapped circuit, the peak inverse voltage is 2 times that of supply maximum voltage. What is the maximum voltage? Generally Vs is equal to Vm into sine omega t. So this Vm should be here multiplied with 2 times. So that is a center tap. Okay. Now we'll go to the next question. In a CRO, the horizontal amplifier is designed for. So in a CRO, the horizontal amplifier is designed for high amplitude signals with slow rise time. Okay, next question, 68th question now. Okay, in single phase transformer, the primary and secondary induced EMFs E1 and E2 are respectively. If you see the phasor diagram of a single phase transformer, x-axis will take phi or magnetizing component of current, and here we have voltage V, and E1 and E2 are there. So the relationship between supply voltage V and E1 induced EMF E1 E2, the angle is 180 degrees, phase opposition. But the question is asked as induced EMF E1 and E2, so they are in phase with each other. In phase means the angle between is 0 degrees, same. Okay, now next question, 69 question here. The transfer function of integral of an integral compensator is given by the transfer function of an integral compensator. So it is given by K by S. So where K is a gain. Okay. Next question, 70th question. Now, if the root locus branches do not crosses the imaginary axis, the system is inherently stable. Okay, thank you friends. So let's continue discussion on the next coming video. Thank you.